with question 1 up here, which is why I put it up here. All right, not a lot to use, so rather than having to explain it 8 times, I just went ahead and put it in the open. So when you calculated your volume, and you multiplied 14.25 times 4.57 times 1.97, and you got your answer. You had 128.291, blah, 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 blah. What do you round to? All right, make significant digits. And how many here? How many here? You need how many here? So 128, and what unit goes on it? CM who? Q. Okay, a couple people asked me if they can write milliliters. Can they write milliliters? Yeah, centimeters cubed milliliters are the same, so I figured that wasn't an issue. Now, when we calculated density, this is where we had the issue. All right, 50.52 over 128, and we get 0.39468, blah, 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 blah. Okay, now when we go to round this, how many significant digits do we need? 3, because we have 4 significant digits here, and we have 3 significant digits here, so we want to round that to 0.394, and then grams per centimeter cubed. I had a few people who wrote grams per milliliter, which again is fine because I said that was okay. Centimeters cubed and milliliter are one and the same. Yeah, 395 is fine. Again, I didn't punch in your calculations continually to make sure you round it up. As long as it was the right answer, I was fine with it. Now, the most made error is what? What do you think people rounded to? Any ideas? It's significant digits, not what they rounded to. What do you think they did? Now, this one they usually have right. It's this one that they have wrong. What do you think they rounded to? They only picked 2 significant digits. Why do you suppose they only had 2 significant digits rounded to 0.39? Because they looked here and they had how many places behind the decimal? 2, so they picked 2 places behind the decimal. All right, try not to get the 2 rules confused. You had 4 significant digits and 3 significant digits. You need 3 significant digits there. You had to have 3 significant digits. So when I graded your lab paper, okay, when I looked at your length, width, and height, you had to have 2 places behind the decimal, 2 places behind the decimal, 2 places behind the decimal, and your volume had to have how many significant digits? 3. So if I wrote -3 SD, that means your volume did not have 3 significant digits. You either had 2, you had 3, or 4, 5. Put it this way, you didn't have 3. When I got to your density, you had to have 3 significant digits. If you don't have 3 significant digits in your density, again, I wrote -3 SD, because you don't have the right number of significant digits. Okay? Everybody see how I did that on your paper? And I'll hand that back. I'll talk about 1 and 2 after I send Jonathan out. He's the only one who didn't do the lab. Y'all might tell him the answer. Let's not give it to him until he makes it up. All right. Question 2, because this is what your quiz is on. All right. 23.4 plus 45.67 plus 3.012. I have 72.082. Everybody get that? Okay, so I added it up right. So when I add, how many places behind the decimal here? 2 and 3. So what I want my answer? So I would round it to 72.1. If you left it at 72.0, I would take that. I would not have any issues with you just dropping it off. I would round it to 0.1, but it would be okay if you did. Okay? All right, make a little space there. Question 2, 14.30 times 3.01 divided by 0.035. I get 1,229.8. All right, this time I'm rounding using the significant digit rule. So I have 4, 3, and 2. So I need how many of my answer? 2. So I only want these, right? But I'm not just rounding to 12. Because if you had $1,229 and I rounded you to $12, would you be happy with me? You want to keep it the same decimal places. You're going to fill in with zeros and round it to 1200. All right, did anybody put in scientific notation? Okay. You could. On the quiz, I'm going to ask you not to. So, this one on the quiz has to be in scientific notation. This one, hold on. This one would be what? Where? Which number? This one has 4. So that's significant. That's 4. This one is 3 because that's between. And this one's a placeholder. So it's not. That's a billboard. So there's only 2 there. Okay. All right. What was the question on this side? Yes. So on the quiz, the first 7, I want you to do a normal notation. And the bottom 3 have to be done scientific. Okay. So like this one on the quiz has to be done scientific. All right, so 3.45 seconds EE or 5 times 4.3 second EE negative 8. And I get 1.4835 times 10 to the negative second. All right, so I want 3 and 2. So how many do I want my answer? Yep, so if I want to drop all these off, I'm going to get 1.5 times 10 to the negative second. And I will also take what? 1.4. If you didn't round up and you left it at 1.4, I would be A-okay with that. Okay? All right, number 3. For those of you who are like, and I do homework, Ms. Wall. All right, this is your question. So when you look at this, or they're asking you to find, if it says how much heat is gained, which letter is how much heat? Q, M, CP, or delta T? Okay, so we're looking for Q. That means we got to know M, CP, and delta T for what's left. So which one of those is mass? Okay, times. All right, how'd you get 0.449? All right, specific heat. If they don't give you specific heat, for those of you who didn't know, specific heat is found on the blue chart. Okay? So, look in the question. Find the compound of the element and look it up. In this particular case, I said iron. So, look up iron, find its number, it's 0.449. So we're going to go write 0.449 right there. Now, the last thing we need is delta T. What do we do to find delta T? Subtract the numbers. And you always want the positive difference. So 95.8 subtract 45.3, and you get 50.5. Okay? Now, to solve, all we need to do is what? Multiply the numbers. So, 35.1 times 0.449 times 50.5, and I get 795.874, and I just quit writing. Now, to do the significant digits, we only look at what's in the problem, not at what's given on the blue sheet. So this number has how many? This number has how many? This number has how many? That number needs 3. So when we round off, we want 796 is fine. If you round it off to 795, that would be fine. Okay? So, this was a gram. That was a joule, gram, degree Celsius. That was a degree Celsius. What are we left with? Cool. There's your answer. Nope. Your quiz is like number 2. Question. What? I said your quiz is like number 2. All right. Can we look at homework real quick? All right. Question 1. Find it so I don't have to repeat all my answers like y'all maybe do yesterday. All right, question 1. The first answer out of the 3 in number 1 is negative 59. The second answer is 318K. And the last answer is negative 423 degrees Celsius. Yeah. All of them? Y'all told me you know how to use this formula yesterday. K equals C plus 273. When the first one, I gave you 214K. So you put the 214 there, equals C plus 273. So if you're trying to solve for C, what do? What do? You subtract 273 on both sides. So that goes away. C equals, and 214, subtract 273, and you get negative 59. No, the only one that you want to be a positive is just delta T. Okay, just delta T. Okay, so you do the same thing in the rest of them. So the next one, you're doing K equals C plus 273. And this one they gave you C is 45. So you're solving for K. So what do you do this time to get K? You just add them. Okay, equals 318. And then you put a K at the end. Does that make sense? Okay. Number 2. You should have an answer of 81.2 joules over grams degrees Celsius. Now, you need to round this for significant digits. What? And you need to round it for significant digits, so you get 80 joules over grams. So yeah, grams over degrees Celsius. Number 2. Did you just look it up on the chart? If you did, it's 0.449. I wanted you to solve the numbers I gave you. Number 3, you get 92.1, which you need to round to one significant digit. So you're going to get 90 joules. Number 4, you get 0.416. You're going to need to round to 0.4 joules over grams degrees Celsius. Number 5, you're going to get 10.7. You need 2 significant digits this time. You can round it either to 11, or if you didn't round up, you can put 10 with a decimal joules. And the last one, you're going to get 1,010. All right, 1010 joules. Now, when you go to put this one in scientific notation, though, or significant digits, this one's a little harder because you have this, okay? And you only want, I think it's 2. Yeah, 2 significant digits. The only way you can get 2 significant digits here is to make this 1100. That's a huge change in the number. You don't really want to make that 1100. The only way you can change this one is to put it in scientific notation to make it the same answer that it was. The only option you have for getting it in the right number of significant digits. Now, which ones do I need to work? 4. All right. So, the number 4, you're solving for specific heat. All right. So, specific heat is which variable? All right. So, look at that question again. Specific heat. Is Q the variable for specific heat? CP. Okay. So, we're solving for CP. So, we got to have Q, M, and delta T. So if we look at number 4, what would the heat or Q be in number 4? So if you keep going there, All right, what's the mass? 6.0. And what's my change in temperature? All right, 30 minus 50 is 20. Remember, that's where we always have the positive difference of the temperature. So 6 times 20, because we're going to combine those, is 120 times CP equals 50. Divide by 120 on both sides. CP equals we get 0.41666 repeating. Okay? So when we look at our given data, we had a 50, a 30, a 6.0, but we only want one significant digit. So the one significant digit we want is this one. So 0.4, and then joules over grams degrees Celsius, which I can get off my chart on the front page. Anybody else? Question on the homework? Particularly for those of us who said I had no idea how to do it. Okay, and number 3, where they ask you to find. Okay, which variable is heat? So it's like Q, M, CP, or delta T. Okay, so we're solving for Q. Okay, what's my mass in number 3? Okay, what's my specific heat number 3? Okay, now, if number 3 is given to us, if they hadn't given it to us, Zoe, where would I find it? Okay, just look it up. Okay, and then what do I do to find my delta T? Yep. So what 2 numbers did they give us to subtract number 3? So what do I get? Yep. So what do I do to find this answer? That's it. So 8 times 0.385 times 30, and I get 92.4. And then I need one significant digit, so I'm going to round that to what? And then put a J on it. And I've got it. No, we do one digit because we have 10 and 40. And 10 and 40 both have that understood decimal point, so those zeros are not significant. And so that's why. Anybody else? No? All right. Let's do our quiz. You need a writing utensil, and that is it, a calculator. All right? Huh? Yeah, I'll give it to you after the quiz. All right. Again, there's no false credit. So if you've got time, punch in your numbers to make sure you didn't miscalculate. I've already demonstrated about 4 in second period, and a couple of people lost points for calculating wrong. All right? Make sure you don't lose points for calculating there. Can't fix it. Just minus 10. Okay? Look it over. Now, the top 7, say, to calculate to the correct significant digit. It says fixed decimal. Fixed decimal is normal notation, like it's on the board. The bottom 3 have to be in scientific notation. Okay? Everybody see the difference? Top 7 have to be in normal notation. Bottom 3 in scientific. Everybody's good with the direction. Okay. All right, and now, there we go. All right, that's perfect. All right, that's perfect. Right talking everything's up. Let's go back. You gotta go. Just go outside. Just go. Oh, I'm telling you. I out of two classes, where was that class? Um, why did you know that? Isabel and later said the questions like two classes. The only people who know they're similar are in the classes. Everybody else, it was just,
It was not similar.
they're supposed to be there the same. They're not supposed to say they're similar. Oh, excuse me. I'm so sorry. I did not mean to try to go. I'm so sorry. Who was your partner? You and the kids. Was there another person? Oh. Okay. So, Jacqueline and Mackenzie all would get credit to say they were the same. All right. Then there's no group that has number 2 correctly. All right. Why would they be on that? Those blocks are made of the same wood. That's a 1x2 board that I went home and told my husband to study 2 inches before each day. Okay? You probably could have, but I didn't know you at the time I needed those. Because pieces of wood are probably, I don't know, 8 to 10 years old at this point. So that's why they have writing on them and little chunks missing at this point. They're a little aged. So, they're made of the exact same piece of wood. So, does density change the size? No, because when your volume went down, your mass did what? It went down. They're proportional. Okay? So your density doesn't change the size. Now, those of you who had really great data, as opposed to had like 0.54 and 0.58, they still told me the densities were different. People, those are the same density. Now, those of you who got 0.4 and 1.2, yeah, you were going to tell me the density was different. There was nothing I could do for y'all. Those measurements were so jacked up. You got the wrong measurements for that. For those of you who had 0.5 something and 0.5 something, you should have told me that these were the same. Okay? You measured the density correctly. Remember what we talked about when we said accuracy? If you were off in the second decimal place, I was okay with that. Okay? You got the same measurement.
not going to necessarily have numbers and replicate identical. You still don't necessarily measure it. That's the place we go one. It's the black, okay? The known digits were 0.5 and 0.5. They were perfect. They were the same, okay? You see where I'm coming from? Okay, they're the same because they're the same block. All right, let's go over this. Now, do we need more practice in teach, or do we feel okay with it? More practice? Okay. We'll take a little bit of time to the next quiz is the pencil Monday. Okay. Now, the longer this is, the less time we have to review tomorrow. So, we have a lab tomorrow, and we're going to take a little notes for the lab tomorrow. So I won't finish it all today. We're only doing one report. We will stop by 10 to 1. I feel like I'm not taking that. This is just to help you guys, because you're like, I need help, I didn't think you will. Alright, we're just doing 1 through 4. Some of you might get all 4 of them done before I stop you. Some of you might only get 2 of them done. We're not going to take more than 10 minutes. Do it in your notes. I'm even going to lay the answers up here so you can check yourself. I'll even put them in correct significant digits, which was a complaint of first period, because I just do it in my head when I call them out. Let me do these insignificant digits. All right. So if you want to check as you go, I'm helping someone. There are the answers. One's in pink, one's significant digit pink. Borrow the pencil, manual. Now let's start. I have lead, carbon, pencil, not in lead, or 7. I dare say your parents, not the lie, the last time. Pencil has lead. Your mom is how old? 2000.
Yeah, right there on the table. Have a question? You all got a couple of them, you want to take it. Works up there, answers up there. Take a look at it. We're talking about 2 minutes. Yeah. Yeah. Rough up. Yeah, you should restart. I have the same to the dad, same to the homework. Okay? Okay. So, those of you who are finished, great. Those of you who need more time and you finish it for homework, then finish it for homework. Okay? If you will, get your next. Okay? Find the next. So what? Just 1 through 4. Okay? Those of you who want to try 5, by all means try 5. Okay? You will not see number 5 on my test. Yeah. Do what? No. It's 4. I'm not taking up 1/3 sheet of paper. The test is Monday. Last I checked the forecast, it looked like we were going to be fine Sunday night for Monday. So I wouldn't bank on that 2 hour delay and not having to do the test on Monday. Looks like all the rain crap is going to have to pass through and the temperature's going to stay high enough that we can be fine. So, and I realize the Super Bowl is Sunday and the test is Monday. I get all that. So, we're going to Super Bowl parties and things on Sunday. And you study before the party so that you can go and enjoy the Super Bowl party on Sunday night. Or just take your chances on Monday and pray you do well. Doesn't matter to me. Or flunk it and do better on the next test. Your call. Huh? 45 multiple choice questions. The only multiple choice test you'll see this quarter. Okay? Remember, wrong answers I get from the mistakes you make in class. They're not junk answers. Okay? So it's very difficult to look at the answers and go, oh, dang, she didn't put any answers on here that are obviously wrong. Okay? I don't make those kind of tests. All right, so let's talk about some vocabulary words that you should know from other science classes. And before you go, I had a crappy middle school experience. You been talking about these words since elementary school, and none of you had all subs in elementary school. Okay? So, here's what matter is. Two requirements to be matter. There's 2 requirements to be matter. And you got the hard one. That's one people struggle with. I have to take a space. I have to have something else. What? Yep. Okay. Matter is any object or material. You can say it's either way. any object that has mass and takes up space. Now, some teachers don't teach it as takes up space. They teach it as has volume. Means the exact same thing. It just depends on which teacher you had and which way they like to say it. But it means the exact same thing. Some teachers just teach it as has mass and volume. They like the shortness of the word. Some like has mass and takes up space. Now, if I was to ask you for some examples of matter, give me 3 examples that are matter. People? What? Sure? What? Sure. Okay, hold on. All right, give me some things that are not matter before you just qualify it as everything. All right, air is the one that causes the greatest issues. Air is matter. If air was not matter, could we have blown up our tires that most of us came to school with this morning? No. Could we expand our lungs and take air into our lungs, or oxygen as it were? No. Okay? All gases are matter. Okay? If not, we couldn't blow up a balloon, can't blow up a tire, we can't inflate our lungs. Okay? All gases are matter. So pick something else. It's not matter. What'd you say? Can't hear you. Gravity. I can live with that. It's the exact same thing you said. Now, you all have a leg up on these things. You've got this Asana. As Asana and Ronnie, you take this Asana too? All right, all 3 of you have a leg up on everybody else in the room. They haven't had physical science. Y'all just popping off answers left and right. Huh? Right. No. Huh? Not crazy about that. I won't say no to it, so I'll go ahead and say yes. Sure, I love that one. Talked about 2 of them yesterday. One was in the definition. I can live with temperature, but looking for something that was in the definition of these 2. All right, I'm going to drop the kinetic and just write energy. All right? All of those are forms of things that are not matter. Now, we're going to talk about 2 other words that we use a lot in this course interchangeably, and they are not interchangeable words. All right, we got up? All right, mass and weight. What's the difference? What's mass? Okay. Yeah, it is. The amount of matter in an object. So I don't want to spend all day trying to fix it. All right, but I know you can tell me weight. Okay. Now, a lot of times people will define that as the force of Earth's gravitational pull on an object. All right, and I don't like to use the Earth's gravitational pull in the definition because weight, or really any object, has weight because of any gravitational pull. At the moment, y'all are sitting in the desk. The desk has a gravitational pull. We calculate it. notebook and the pen you're all using have a gravitational pull on it. Why don't you feel it? It's so small. Okay? When you think about objects that have a gravitational force that we can feel, they're gigantic. Moon, sun, Earth, planets. They're just gigantic. These have gravitational forces, but they're very small. Distance and mass are the two things that affect gravity in a way that we can feel it. So, if we consider mass and weight, all right, how are mass and weight different? How are they different? Don't give me the definition. Yes, pounds is English, but if I was doing this in physical science, for example, this one would be done in grams, and this one would be done in newtons, in terms of actual use. I'll tell you that. But that's not the reason. Anybody? All right. Let's say that the moon has I got a Tesla here, and I got some. What happens as I travel from one to the other? Okay, gravity changes. Who has the most gravity? Okay. Why do I have the most gravity? Okay. Initially. Okay. And we know that because this is small. Roughly 1/5. We went to the moon. You can take your weight and divide it by 5. I'd love to go to the moon. Never going to Jupiter though. All right. So if we consider these things, my weight's going to change based on my location, right? What's not going to change? Okay. So weight changes with location. Mass does not. So, if I stick Ava in a spaceship, send her off to the moon, her weight's going to change, her mass will not. The only way I can change Ava's mass is to do what? That's going to have to be this way. Okay? Love walking on. Keep it here, then the rest. Okay? That's the only way I'm changing her mass. Her weight will change because the force of gravity will be different. But her mass will not be altered unless we literally lop off some body parts. Everybody with me on the difference? Okay. The remainder of our 20 minutes, we're going to talk about the difference between physical and chemical properties. If we have any remaining time, we'll talk just briefly and begin to talk about physical and chemical change. We will have to talk about most of physical and chemical change tomorrow before we do the lab. Okay? And that's on the agenda for tomorrow. If you're out tomorrow, you're missing another lab. It's an easier one. Very little measuring in it. There are some significant digits, but not very many. Everybody have what they need. Okay. All right. We'll start with physical properties. Physical properties are properties that do not alter the identity of a material. Okay? These are properties that do not alter the identity of a material. So, I want you to look at my desk up here. I also want you, before you start yelling out properties, to pretend I don't have notebooks sitting on it. I don't want properties such as my desk is neat or my desk has crap sitting on it. Okay? What properties can you give me to describe my desk other than there's stuff on it? What? Color. All right. Color is good. All right. Color is a physical property of my desk. All right. What else can you give me to describe my desk? The shape. Okay. I heard one over here on the other side, but I couldn't make out what you said. The material it's made of. Sure. What else? All right. Give me something specific to talk about size. What things have we measured about it in the last few days that we could be more specific about size? Sure. And? Sure. Stop volume. What else can we say about my desk? Is what? Sure, say it. That would be material, but yes, that would be good. It's okay. Huh? Sure, let's put like 1 point or melting point. Here, I'll write them out. All y'all don't know the abbreviations yet. So, I just got to say 1 point, melting point. Okay. Anything else? There you go. At least one of them. All right. Now, one of the things you're going to have to do tomorrow in the lab is you're going to have to tell me if they're intensive or extensive. Now, physical properties only. Okay? So in a minute, when I talk about chemical properties, are we going to come back and label these as intensive and extensive? So tomorrow in the lab, are you going to label chemical properties intensive or extensive? No. Right, how many people are going to tell me this tomorrow? All right. If they're intensive, they do not depend on size or amount present. If they're extensive, they do depend on size or amount present. So, for example, Jonathan has a lovely orange pudding. If I cut it up into 6 pieces and throw the 6 pieces around the room, will the color change? That is an intensive property. It does not depend on size or amount present. Its pudding will stay orange no matter how much of it we have. If I cut it into 20 squares, will it still be an orange hoodie? Yes. Okay? Everybody happy? Doesn't matter. We're not talking about that. We're talking about a physical property. We're not talking about chemical right now. Okay? So we're going to have color. Color was here. Okay? That's intensity. Now, the shape of my desk. If I cut it up into 6 chunks, is the shape going to be the same? That is extensive. Will the material change if I cut it up? It's still going to be wood. Intensity. Is its height going to change? Extensive. Is its length going to change? Yes. It's extensive. Is its width going to change? It's extensive. Is its width going to change? We're on volume. Sorry, I said width. Yes, its volume should change. What about its weight? Yeah. I would certainly say if we broke it up, its volume is going to change as its weight. All right, what about its mass? If I broke it up and I threw one area over there and one over there and one over there, I'd say its mass is going to change. All right, how about its density? That's correct. What we just talked about a few minutes ago. Density is intensive. It's state. It'll stay a solid. How about its boiling and melting point? No, it's not going to change. The only thing about boiling and melting that changes is time. So if you have more of it, it takes longer to melt or longer to boil, but time is not a factor in intensity and extensity. And texture. No, that's not going to change either. All right. Now, everybody got it? So, what's a chemical property? A chemical property is a property that will alter the identity of a material. Now, sometimes when we talk about physical and chemical properties, and even tomorrow when we talk about physical change, some of you are going to be like, after we do this, it's long, you don't get it. But after we get to the very last section, when we get down here to the bottom, and I talk about the 5 indicators, and there are 5 indicators I'm going to talk about tomorrow. Don't write them down, I'm going to write them on the board. We're going to talk about color change that's unexpected, producing a gas, producing light, change in temperature, and which one did I forget? Formation of precipitate. Did I say that one? Precipitate, color, temperature, light, gas. Okay? Those 5 things. If any of those 5 things happen, then it's a chemical change or a chemical property. If none of those 5 things happen, it's automatically what? Physical. So once we do that tomorrow, it'll be easier for you to decide if it's a chemical or a physical property. So don't get bogged down if you're like, I still can't tell. You'll be able to tell tomorrow after the lab. That's what we're doing. Now, things that are chemical that you might know. All right? Flammability. And this list will not be nearly as long, because you don't know a lot yet. All right? Flammability means to do what? Catch on fire. Everybody has seen something catch on fire and burn. Once it's burned into a pile of ash, can you change it back into what it was? No. Of course not. So it has altered its identity. We cannot make it go back into what it was. All right? A lot of you are familiar with the term oxidation. So for those of you who are, tell me what it means in a general term that other people will know. It does change color because it's called what? Rusting. Okay? Yes, I will eventually. Not today. All right? But oxidation is a fancy word for rusting. So if you have a car that maybe has undergone some oxidation or some rusting, let's just say it's white. It's a white car and it has turned brown, which is the color of rust. Can you make it go back to that nice white color? No, it has altered its identity and is not going back. if any of you have a compost pile or you've watched something decompose, once it has started down that path, can we reverse it? No. Okay? If you have acid reflux or maybe your parents have heartburn, we take an antacid to neutralize whatever acid is built up in our stomach. Maybe you have an upset stomach. Take some Mylanta, some Pepto-Bismol, some whatever it is you drink that you like when you have an upset stomach to help settle your stomach. I'm not talking about Sprite, but some other kind of medicine.
Exactly, Campos to find out.
Okay. Before I forget. All right, we could talk about something being synthesized, which we will talk about when we do types of reactions. We can talk about something undergoing combustion. Okay, any of those would be chemical properties. Now, can I go back to the last slide and pick up intensive and extensive for any of those things? No, we said we could only say what about intensive and extensive? It's only physical. Everybody got that? Okay. So, where we're going to finish today is just a brief discussion of physical change. And we'll pick this up tomorrow just to get started. Now, the second part of your lab tomorrow is on physical and chemical change. Now, physical change will not alter the identity. Okay? So what does that mean? The material will keep all its original properties. All right, it keeps all of its original properties. Because tomorrow, when we talk about chemical change, is it going to keep its original properties? No, it's going to get all brand new properties. So, when we talk about some examples of this, odds are good that if you had anyone teach this to you in middle school or whatever, that you probably talked about things like cutting, maybe grinding, tearing. Okay, so if you have a piece of paper, like you're using right now, and you rip it up, okay, tear it up, did it get any new properties? No. All right, if you help out in the kitchen, if you take a foods class, you take a pepper, and you cut it up, you grind it up, you mash it up, does the pepper change in any way? No, it has all of its own properties. Nothing changed about the pepper, okay? Now, the part that confuses students that we'll spend more time with tomorrow are the state changes. Can anybody tell me anything to remember about state changes? So we can write down a couple of them maybe before we go? Oh, you don't have to give me attention. You don't have to be free. Okay, we'll get to that later. All right. Can anybody tell me the opposite of freezing? Okay. All right, boiling. Not picky. All right, so boiling changes from a what to a what? Okay, it doesn't have to be just water. All right, however, boiling needs a whole lot more to it than just liquid to a gas that we'll get to later on in the spring, and y'all will be appalled at what you need to know about boiling. All right, but without it just being boiling, what is just a plain old liquid changing to a gas? What do we call that? Evaporation. Can you tell me the opposite? Mm-hmm. And there's one more, depending on who you had for a teacher, you might have talked about the first one out. Just making this stuff up. It's called sublimation. Anybody know what it means? Okay, we're going to talk about what those all are tomorrow. Some of you remember, some of you don't. All right, so homework. This is like super easy. All you got to do is put a check mark, and whether it's chemical or physical. It'll probably take you 60 seconds, maybe 120 to read slow. Okay? This is like less than 3 minutes worth of homework. That's true. Or if you're in some people's category, you lose the whole worksheet. It's going to take less time. Right. You remember that you could look on the website homework plus or download the homework or look it up and it's on the website. Put your calculators in the bucket. That was it for Luke. And if I should forget to post it, you could always send me a remind message and say, hey, Ms. Wall, you forgot the homework, and I can post it.
I got you. Yeah, you got me. Are you saying after this?
Yeah, I'm here.
I'll come.
I'm here.
He's gonna buy all of them.